All right. Hello and welcome everybody to the December 2018 monthly 3D printing and 3D design webinar. My name is Nick Klosky and I am one of the co-founders of Honeypoint 3D, and I welcome you to the webinar. I also welcome everybody who is watching this on replay as well. We've taken a little hiatus in the last couple months to work on some new materials and some new classes. So I want to kind of tell you about Honeypoint 3D a little bit, and then we'll get into learning about some techniques that people have asked in this previous month about how to accomplish some things with Meshmixer and Fusion 360. And I invite anybody who is on this live webinar to ask me questions. And afterwards, if you're watching this on replay, I'm also open to answering some questions about 3D printing and 3D design, whatever you need to know by emailing me. And I'll give out my email in a little bit. First of all, I want to give a little overview of what Honeypoint 3D is. So we are kind of a half and half company. Half of our company is mechanical engineering. So we create 3D models, CAD models, models of all sorts of different things, from people who come into our office, individual inventors, people that just have an idea and sometimes even just a napkin sketch, all the way up to reverse engineering hydroelectric power plant turbines. We did that about a year ago, right? So we help create 3D models that then flow into 3D printing, CNC machining, design, all of that. The other half of our business is education. So if you look on our website, you'll see some links to our classes, and we offer classes on Fusion 360, on Meshmixer, some intro to 3D printing classes, and essentially classes all about how to learn 3D printing and 3D design. Today, the examples that I will be giving on the software will be about techniques you can use in your own modeling workflow to work with, in this case, 3D scans going into solid modeling. And if anybody has any questions online about 3D printing or filament or anything about that entire world of additive manufacturing, let me know. All right. What I want to talk about first is a question that came up about how to use and utilize 3D scans inside of Fusion 360. Fusion 360 is very good at handling 3D models that are made from 3D scanners, but those models are not solid models. They're shell-based models, polygonal meshes, things like that. They're not solid models. The question is how you can do some pretty accurate things with Meshmixer going into Fusion. I want to give you an example of what that is. So let me share my screen here like this. All right. This is an example of a little piece of something that I 3D scanned, a little mechanical shape. You can see right here, this is in a Meshmixer, by the way. We have some screw holes here, some other kind of shapes on the side. You can kind of see some of the tape that I used to help get a good scan off of this. And the question is that we wanted to recreate these little bumps on the side, these little ridges in a solid model. Now, the problem is that these are all on kind of different planes, and this would take quite some time to reverse engineer if you didn't know some tricks. So I wanted to share what a trick was to try to get that ridge right there. Now, a lot of people think that Meshmixer is not a very accurate piece of software, but it actually is. And the trick that most people forget is about the fit primitive command. If I do a little selection right here, and I go to edit to fit primitive, or also bound to the P key, I can put in a square. You can't really see it here until I raise this up, but you can see that there's a square that is matching kind of the average of my selection, perfectly matching that. But what I can actually do is if I select the flat place on this side and even go down very small here and select the flat plane on this side, and I go to the fit primitive command, and I select up here and say single primitive. What that will do is it will connect those two selected areas with a flat, absolutely flat plane. And I'm going to say create new object and click accept. And now you see in our little object browser, we have our plane example, but we also have this primitive. And that's the one that I want. So I'm going to export this as the plane. And I'm going to export this as the source plane. Now, what I'm going to actually do, I made a little mistake with this. What I'm going to do here is take this plane and export this actually as a plane, but in the OBJ format. That is kind of really critical to this workflow. Export that as an OBJ. Now, there is a great piece of software called Instant Meshes. This is software that is free. You can look for it if you just do a search for Instant Meshes. It is free software. What I'm going to do is open the OBJ that I just created. Now, you can't really see it because this is just a plane. This is normally used for more complex models. But what I'm going to do is just click Solve, Solve, Export Mesh as a pure quad, and Extract. And now we are able to see it. You see, just some squares, but that is all that we need. If we click on Save and save this as plain OBJ in quads, that is what we need. Now let's go into Fusion. What we would do in Fusion is insert the source plane like this. That is great. And we will also insert the mesh of the plane quads. And that came in right there. And you can see that that is perfectly aligned because it kept the coordinate system. We click on Create Form, which is the sculpting environment, and we say Utilities to Convert. And in Convert, we go to Quad Mesh to T-Splines over here in the menu, Quad Mesh to T-Splines, and we click on the Quad Mesh. Very fast conversion like this. And we click on Finish Form. There we go. If we turn off the source file like this, we have a solid model, right? You can see that this is not marked as a mesh. It is marked as a solid model. So that is great. What we would do then, if we bring on this guy right here, we can actually now reference this. If we say construct a plane through 3 points, we can click 1, 2, 3 points on this converted solid. And now, even if we get rid of this solid, we now have a sketch plane that we can use that is perfectly aligned, you can see that, to the bottom of this ridge. We can now do whatever we want with, creating different sketch geometry around here. I'm just doing this super duper fast, but we just have some sketch geometry there. And we can offset that to whatever we want this to be, 7 millimeters, something like that. And let's just close this off like that. I'm going to hold down my mouse button and select this profile and extrude it out to this extent. And then we would go in and do maybe some filleting, but probably if I were actually doing this, I would be a little bit more conscientious about how to actually make the curve, fully match. But this is good enough for example's sake. Something like that. We would then go and, the actual probably better way to do this is to do a sweep over the profile, create a profile here and then sweep it along a line. But nevertheless, we have created something that is right on this plane. We would do the same thing and create planes for these, and it is kind of a shortcut for creating planes on here. Here we go. That is just a little bit of a shortcut on how to use Meshmixer in a more accurate way. Assuming that you have some sort of access to a 3D scan, you can bring in that scan and use that Instant Meshes program, which is really, really powerful and free, and bring it into Fusion to do some solid modeling. So that's pretty cool. I used that in actually a couple of projects over this past month, and it was very, very useful, and it's kind of just a shortcut to use. Now, the other thing that I wanted to talk about today was just a cool feature of Fusion 360 where you can make some more organic shapes, but using more structured shapes. And what that is this would be more for artworks or conceptual design where you want to add a little bit more organicness to the very rigid area of Fusion 360. Let me go and share my screen here like this. I think that's what this is, like that. All right, we have the number 1 right here. All right, so we have the number 1. This was just created with a sketch of a piece of text, and then I exploded that text. So we have number 1, so each one of these lines is its own little element and addressable right here. And I'm going to create an offset plane right here. And I'm going to create a sketch on that plane. I'm going to hit the project button, which is P. P is for project. I'm just going to click on all of these lines. And if I kind of rotate around, you can see that I'm projecting one line to the other, like that. And now I'm going to say stop. All right, so we have some ones that are kind of just floating here in space. The same number 1, but just kind of mirrored to each other. Now I'm going to create another sketch. This actually doesn't matter where this sketch is. I want to make sure that over here in my sketch palette, I have 3D sketch turned on, because that is important for what we're doing. And I want to go like this. So what I'm going to do is hit just the L key for line, and I'm going to allow Fusion to kind of snap from this to this. And what I did is I connected those two number 1s with a line. I'm going to do the same thing for each of the kind of major points here. I have to kind of accept it each time. But what I'm doing is making a 3D number 1. Maybe I'll connect that one in there, and then this one to there, and then the other bottom one from here to here. I think that looks like a pretty good connection. So I'm going to click Stop Sketch. So now we have this 3D one. Now the really cool thing about all of this is you can go into the Create Form command right here. So Create Form, and you want to create a pipe. And you can actually click on all of these. So that is a way too big pipe. Let's make this a 5mm, and then let's turn this display mode to the circular. So that's one path, but now look, as I click on these other, I'm not even going to chain it. As I click on these other chains, you can see that the pipe is actually adding in to each other. And I click on all of these, the pipe kind of follows down. But I can click also on other, like essentially every single part of every single line inside of here. As you click on it, Fusion will figure out how to connect all of these together. So as I click on these, actually I think I unclicked on one of those right there. Awesome. And now we're done. We have this really cool one. It looks like I forgot one line there. I can always double click back on the form down inside of here, make sure that my sketch is turned on, and create. Actually, I can just double click on this pipe command right here and edit it. I should be able to click on that section right there. There you go, to edit that back in and go finish form. So what we have right now, if I turn off all of the sketches, this is a full solid model that has tangent connections between every single aspect right here. If we do under inspect, a section analysis, maybe on the origin right here, we can see that this is a full solid model. You can see that it's filled with material. We could export this. Actually, let's just try that. We can export this solid body, as you see right here, as an STL. And if we open this up in Meshmixer and import the pipe, we can see that we have a full solid body. Oh, it looks like I missed one down there. But if we hit W, you can see that this is just a full thing. It's all ready for 3D printing. We go to Analysis to Inspector, no problems with it. Fully ready for 3D printing. And you might need some support material, but it is a pretty cool workflow that you can use all inside of Fusion that is all just based on blocky sketch connections with each other. Let's go back here and go back here. That actually came up in this last month. We were doing a thing for a client where we were creating some more mechanical shapes, but the edges of those shapes, the client wanted them a little bit more rounded, but not in terms of filleting, which creates a very mechanical routing, but have some sort of crazy cool design on the outside. Any line inside of Fusion or any edge inside of Fusion can have a pipe added to it. The edges inside of Fusions could be considered as construction geometry to be used for other things. Now, edges might just be edges for your shapes, but they can be used in other ways, which is kind of the point of why I brought that example up this time. Now, if anybody has any questions on any of this, I would invite you to use the chat feature to ask them. If you want to learn more, let me share my screen again. You can always go to our website. Let me bring up another version of Chrome here and go to honeypoint3d.com, which will come up right here. So honeypoint3d.com is my company. I'm one of the co-founders of that. We have 3D services. We also have links for education. Contact us, get a quote. We are also authors of the best-selling 3D printing book on Amazon. It's in first edition. We are very, very close to coming out with a second edition. I would invite you to look for either the first or second editions when those come out. But it is the #1 selling book on Amazon for 3D printing, which is great. All right, let me go back here. Back to me. Well, I don't see that anybody on the viewership has any questions, but I would invite you to ask me any questions after the fact if you want. My email is it's very easy, Nick, N-I-C-K, @honeypoint3d.com. And you can find my information on the YouTube channel as well. And I really appreciate everybody coming today and listening to this webinar, especially if you listen to it on replay later on. And I wish you a great new year. And I hope that all of your 3D printing and 3D design workflows and what you try to do this year create something awesome and great. Thank you very much and have a great new year. Bye-bye.